Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time. Here is question 22. Given the following data set, and then we have all these numbers, which representations are correct for this data? So first we have a dot plot, then we have a box and whisker plot, then we have a histogram. So let's go one by one and see what is a correct representation of this data. So I happen to be a data analyst, so I really like this question. So a dot plot, so these are super easy. So let's see if this correlates to our data. So we have one value of 65, 1, 2, 3, 4 values of 70, 1, 2, 3, 4. So that looks good. 3 values of 80, 1, 2, 3, 1, 2, 3, 80, 85, only one value. 2 values of 90, 1, 2, 3 values of 95, 1, 2, 3, 1, 2, 3, and then one value of 100. So yes, this dot plot correctly represents this data. Next, let's look at a box and whisker plot. So if you remember, box and whisker plots are based on the minimum, the maximum, and then these are all quartiles. So this is the quartile 1, quartile 2, and quartile 3, and they're all different medians. So this is the median of the entire data set, and then this is kind of like the upper median. So it's like the middle of the top half of the data set, and then this is the median of the lower half of the data set. So I have a video on this if you want to see more about this, but let's go over this quickly right now. So to find the median, we want to see the middle number, and luckily they give this data set the numbers already in order. So since they're in order already, we just have to count to the middle number. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be our quartile 2, 80. So that looks correct. Now we find quartile 3 by looking at the middle of this section of the data. So 1, 2, 3, 4, 1, 2, 3, 4. So we know that 95 is quartile 3. So that also looks correct. And now we're going to look over here for quartile 1. So 1, 2, 3, 4, 1, 2, 3, 4. So this is the middle number 70 for quartile 1. So quartile 1 is 70, that also checks out. And now for the minimum, the lowest number 65 and the maximum 100. So this box plot is correct and represents this data perfectly. So I'm just erasing this so we can assess it again for that histogram down below. So this is basically asking the interval, the numbers between 61 and 71. How many numbers do we have in that range? And then we mark it down in the frequency. So if we look at numbers 61 to 71, so that would be the numbers here. So if you notice, we have 1, 2, 3, 4, 5. So we have 5 numbers at that frequency. So, which is exactly where this histogram is marked. So we know that this part is correct. The next part, we have 71 to 81. So numbers 71 to 81 are represented right here. We only have 3 80s. So that's where this aligns. That's also correct. Now 81 to 91. So that would just be 1 right here. We only have 81 to 91, we have 3 numbers right here, right? That would be included in that interval, 80, because we have 85, 90, and another 90. And that also aligns perfectly with our histogram interval. And last but not least, we have this interval 91 to 101, which is the last 4 numbers, which is represented right in the correct way on this histogram. So they are all included, they're all correct for this data set. So the answer here is choice 4. So now for number 23, a recursively defined sequence is shown below. So this says a sub 1 is equal to 5, and then it says a sub n plus 1 equals 2a sub n minus 7. So don't freak out with these recursive formulas. They're just like a pattern, and you get used to answering them. So the first thing we're always going to want to do is write out a sub 1, which they give to us, is equal to 5. I have a video on this if you want to see more recursive formulas and practice that. So let's write out our first term. So that's what this means. The first term equals 5. And then now we have this kind of crazy looking thing. And what we're going to do is just plug in this 5. So we have 2. So it says a sub n, but we're going to plug in 5, this value that we had before, minus 7. So when we do that, we get 10 minus 7, which equals 3. And now on to the next term, the third term. We're going to write out 2, the formula they gave us. And now we're going to plug in 3, the last term that we just found, minus 7. So we're just following along with this pattern and plugging in the previous term value that we get. So 6 minus 7 is going to be negative 1. And now we have our last term, the fourth term, which is what we're trying to find, equals a sub 4, 2 times now negative 1 minus 7. And this is negative 2 minus 7, which is just negative 9, which is our answer for this question, choice 1. So here's, I don't know if this is like neater to look at with the highlighted purple, but this is just how we solved it the same way. Yeah, don't get freaked out too much by the notation. Just focus on always using that previous term value. So number 24, so this is the last question of our multiple choice section here. So it says, which polynomial has a leading coefficient of 4 and a degree of 3? So this is an easy question. It's just we have to know what each of these terms mean, leading coefficient and a degree of 3. So a coefficient is always the number that becomes before a variable. So if we want the number before a variable to be 4, then we're going to have the number 4. And now the degree. So the degree is always the exponent value of a variable. So if we want a degree of 3 and we see working with all these unknown variables of x's, so we know we're going to be having x cubed. So here I just highlighted the coefficient is 4 and the degree is 3. So now we just need to kind of do some scavenger hunting to find 4x cubed. So we don't see it in the first one, so we know it's not the first one. Not seeing this in the second choice. I don't see it anywhere in the third choice, but I do see it right here at the end, 4x cubed for the fourth choice. So number 4 is our answer. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!